right, we're here today at Wentworth Scrap Metals outside of Portsmouth, New Hampshire with John Hebert, the owner of the business, to show him the new laser-based technology, the Z100, that uses a laser to analyze metals as opposed to X-ray. I was just showing to John, this is the actual analyzer, and one of his questions was, how does it, like, what does it shoot at the material if not X-ray? So what this does is it fires a laser. The laser comes out of this little aperture and is focused at the front surface. So the laser makes a small burn into the material. A good example is this copper alloy. We can sort of see the burn, little mark it makes. So it sort of ablates off a little bit of material and vaporizes it, and as that cools, it looks at the light that comes from the various elements that were in that material. So it looks at optical light as opposed to X-ray light. There's a camera inside, so you can see when the material is in front of the window. Right. And you can hold your fingers there because there's no X-ray. You would never do this with an X-ray. No. But you can hold your finger there and shoot stuff. So on turnings, instead of shoving the thing into barrels of turnings, you can just grab a bunch of them and hold them, test them, set it up to do an average. Yeah. So it can give you an average chemistry of your bucket. Okay. You know, with the X-ray gun, and maybe you've experienced this, you start shoving that thing into turnings, right? You poke through the window, right? Problems. Bingo, yeah. 8 to 10 grand broken detector. Oh, yeah. What I like to show people is just as an example, this is a little hex wrench. There's the window. Right. I mean, I can do this all day long. Wow. You know, you're not going to break anything. We're just going to pop off this window real quick. Because you're looking at optical light, not X-rays, there's a quartz shield. Okay. So what you see there, the middle thing is the laser. That's where the laser comes out. Right. The lens up the top is what collects the light from the analysis. Okay. And the lens down there is the camera looking in. But the nice thing is, since that's thick quartz, you know, you can't penetrate that. Right. You can whack on this thing all day long. So there's no detector to break. We make the laser and we make the spectrometer. So as I tell people, our maintenance costs are less than 1/10 of an X-ray device. Because if you somehow drop this a lot, or you manage to break a laser, it just means maybe you've knocked a mirror loose, or you've got a part that you've knocked loose. But we can just repair that component. Right. X-ray tube, when an X-ray tube fails, the only thing you can do is a full X-ray tube replacement.
How is the battery charging this?
The batteries should be good for a good 8 hours. It's right there, sits in there. Because again, these don't draw, except when they're actually firing, which is only for a few seconds. Right. They don't really draw much power. When you shoot stuff, I just kind of keep samples. You pull the trigger, you can see the plasma being made, and there's your ID right there. Right up, and there's your 836. So you get your chemistry, your grade ID, and you get a grade comparison for things that are in or out of spec. Yeah. But on the recycling side, most people are interested in the what it is, the basic chemistry. Right. Exactly. Yeah. One of the disadvantages of X-ray is on the aluminums, because you typically have to do a 30 or second or longer test. For some aluminums, you can do a faster test. Some you can't, but it takes a pretty knowledgeable operator and an alloy person to make that decision. If you don't wait long enough for that magnesium measurement, it'll call something. It might call something a 6,000 that's really a 5,000 with high mag. So that's the thing. And so the nice thing about this is it's a same test time for everything. And you know, customers say, well, how do you compare this to X-ray? And what I tell them, rule of thumb, is laser is much faster and generally better on aluminum alloys, because you can measure low magnesium really quickly, low silicon, and it's generally faster on red metals. Right. Because you can pick up the aluminum and the aluminum bronzes very quickly. Right. And the other thing this does, it's become a real issue, is it measures an element called beryllium in copper alloys. You get a lot of beryllium coppers you start seeing, and beryllium's a real hazard. You can't really machine it, cut it, because the beryllium is quite toxic. Right. So you can't measure beryllium with X-ray, and you can measure it very easily with this. You know, most recyclers and most metal places, 90% of their material is aluminum, coppers, and stainless. Right. If 90% of your volume is in the sort of sweet spot of laser, that's kind of a good match. And then you don't have the safety and the maintenance costs either. Exactly. So you shoot this, So this has come up as a cast aluminum, which is not surprising because it looks like it's a cast aluminum.
Right.
So it's come up with a 2000 series, which is kind of typical. You've got high copper.
Right.
I mean, X-ray's fast on some things, but you know, this is much faster than aluminum. It's about 10 times faster.
Right.
So it's now it's worth sorting this stuff. I was pulling these out.
Yeah.
You know, that's a 7000, 7075. So yeah, you don't want to mix these guys up.
No, you leave money on the table.
Yeah, and you know, I don't know if you sell it as a 61 and it's a bunch of 7000s.
Right.
What does that mean? You know, so that piece is a 60 now.
Right. It's on 316, 317.
Yeah.
316L.
Yeah. Yeah, 316.
Yep, 316. Yep. Yeah. So in the day, this would normally just go as stainless because the magnet wouldn't stick to it. You know what I'm saying?
Right.
So you kind of lose money versus like a 304L.
Yeah. I mean, you can do that. Like we shot this piece, and you know, a lot of times you can just visually pull out every tube.
Right.
Maybe shoot a few more to make sure we just didn't get lucky.
Right.
And but yeah, now you've got a stainless, a 316 upgrade right there. Yeah, that's 316 as well.
Yep.
So.
There's a regular stainless here. Regular meaning you call it 304.
Yeah. Yeah, 304.
304, yeah. And it is quick.
So right now you said you use an X-ray,
right.
a handheld X-ray device.
Right.
And so what have been some of your experiences with that in terms of? Because I noticed you haven't really had it out here looking at stuff.
No.
And I was curious.
You got to be real careful. It's real. It's delicate. So it's not. You have to have time to just set aside and do all your work, and you have to pay attention because if it gets knocked off of something, or if it's even down low, it breaks big expenses. So that's That's one of the downsides. The other downsides, we have so many regs, government regs, everything else. Registering it, paying to register. It's $350 to use to buy something and to use. Every year, and then the tags, the badges you have to wear to make sure you're not getting too much radiation.
Right. Some of the recyclers that do travel from state to state, either to go out and bid in material or just have facilities, then you got to pay those fees in every state every year.
Right,
so
like
now,
that.
Now you're up over. You might be a couple $1,000 a year in fees.
Exactly. It made me nervous. I said, I was going to go to Massachusetts and do some work, and I said, I don't even know if I can bring it into Massachusetts.
So recently, up until the laser came along, X-ray was really the only game in town,
Right,
and
right.
On the repair side of this thing, one of the things we wanted to do when we designed this was because a lot of us came out of the X-ray business, so we were familiar with these expensive detectors, expensive X-ray tubes. And those issues. So that's why for the laser, we ended up getting our own laser technology. So we make our own lasers now.
Right.
Make our own spectrometers. Probably the total cost of a laser is not much different than an X-ray tube, and a spectrometer is less than an X-ray detector. But the reason we can repair them so quickly is because we can repair them in a modular way. So, like I was saying earlier, if a grating or a fiber breaks or comes loose, we can just replace that. It's like, it's like if you take your car in and it needs a new carburetor, they don't replace the whole engine, right? That's kind of the example. You're talking about a repair on the order of $500 as opposed to $8,000, right? And you don't have the regulatory side. You don't have the badges and the fees. And I think that'll really change the industry because now there's an alternative to those high maintenance costs, and that's what we're trying to explain to the alloy industry and the recyclers is that laser, it's a little different. I mean, in terms of what it's better at versus what it is not good at compared to X-ray, but it's definitely. The maintenance costs are at least a factor of 10 lower.